Chapter 4, Part 5, we are talking about the elimination method. Here's example number 54, Part A, from page 27 in the note packet. So we have 2y minus x equals 5, negative 3y plus x equals negative 9. The first thing you're going to do is you're going to see, can you add these equations together and will something eliminate? So we're going to try that. We're going to add them all up and see what cancels out. 2y minus 3y is negative y. Negative x and positive x cancel out, which is what we wanted to happen, and then 5 plus negative 9 is negative 4. So we were able to eliminate a variable, and now we're going to solve for y, so y equals positive 4. Through the elimination method, we are able to eliminate a variable. Now, once we know y, we have to go back and plug it into one of the original equations, so it does not matter which one you choose. I'm going to pick the first one, so we have 2y minus x equals 5. Since I know that my y is 4, I'm going to plug it in for that equation. So we'll have 2, and then in parentheses, instead of y, it's 4, minus our x equals 5. So that will give us 8 minus x equals 5, and then we want to solve for x. Divide or subtract 8 on both sides. Negative x is equal to negative 3, and then we want to get x by itself. So x is equal to 3. Now when we go to write our answer, we're going to write it as an ordered pair, so 3, 4 in parentheses. So we are adding the equations together to get something to eliminate. We're going to take a look at the second example, 54b, same page, page 27. 2x minus 4y equals 14. Negative x plus 4y equals negative 3. Again, if I go to add these together, I'm looking to see if something will cancel out. 2x plus negative x is x. Negative 4y plus 4y cancels out. 14 plus negative 3 is 11. So we got the y's to cancel out. They were eliminated, and we've solved for x. Now we're going to take the x and plug it back in either of the equations. I'm going to plug it back into the first equation. Again, it does not matter. Because my 11 is equal to x, I will plug 11 in for x. So we'll have 2 times 11 minus 4y equals 14. So it'll give us 22 minus 4y equals 14. And then we can solve for y. Subtract 22 on both sides. Negative 4y is equal to negative 8. And divide both sides by negative 4. So y is equal to 2. And again, we're going to write our answer as an ordered pair, 11, 2. So these worked out nicely. We were able to eliminate a variable by just adding the equations together. In this example, number 55, also from page 27, we're going to do the same process. We're going to look to see, can we add these together and will something eliminate? So when we add them, we'll get 4x plus 10y equals 18. Nothing is eliminated, so we do not want to just add them together. So this is not what we want to do. So I'm going to rewrite the problem again. Now we want to look to see, can we subtract them? Would they cancel out if we could subtract them? So if I draw a line, and when we subtract them, we have to change all of the signs. So now this becomes a negative, this plus sign becomes a negative, and this 5 becomes a negative. So my two x's are going to cancel. We now have 4y is equal to 8. So we were able to eliminate the x's by subtracting the equations together. So y is now equal to 2. Now we can plug 2 back in either of the equations. I will pick the top one just because, doesn't matter. And because my y is 2, I can plug 2 in for y. So we have 2x plus 7. Instead of y, we'll plug in a 2, equals our 13. So 2x plus 14 equals 13, and we can solve for x. So 2x equals negative 1 divided by 2. X equals negative 1 over 2. So our ordered pair is negative 1/2, comma 2. So we can eliminate, but this time we're using subtraction. This is example 56b on page 28. So we have these two equations, and again, we want to see if we can add them together and if anything will cancel. If I look at my 5m and my 3m, if I add them together, they're not going to cancel. If I add my 2m's together, they're not going to cancel. So we can't add them together. So instead, we are going to try to subtract them. So I'm going to rewrite my equation. So we have 3m plus 2n equals negative 2. So I'm going to draw my line, and I'm going to now subtract. So this becomes a negative 3m. My plus 2n becomes now a negative, and my negative 2 becomes a positive 2. So now when I add them together, we have 2m, the n's go away, and it's now equal to negative 8. We can divide both sides by 2, so m equals negative 4. We were able to eliminate a variable by subtracting them. Now that we know m is 4, we're going to plug that back into one of the equations. I'm going to plug it into the top one. So I'm going to take negative 4 and plug that in for m. So 5 times negative 4 plus 2n equals negative 10. So it's negative 20 plus 2n equals negative 10. We'll add 20 to both sides. 2n is now equal to 10, and we can divide both sides by 2 to get n equals 5. So when we go to write our final answer, we'll have negative 4, comma 5. So they are eliminating by subtraction. In number 58, we are going to do the same thing. We want to solve for x and for y. But if we look at the problem, we can't add them together and have something cancel out. We also can't subtract them and have something cancel out. So we have to look to see what could we do to maybe modify or change this equation. So currently, we have a 4x and a 9x, a 3y and negative 4y. Now when I go to look at these problems, and if I can't just add or subtract them, I look to see what has opposite signs. So I see that there is a positive y and a negative y. Now 3 and 4, we can't take anything times 3 and make it 4. And we can't go opposite, multiply anything by 4 and make it 3. But what we can do is multiply the top equation by 4 and multiply the bottom equation by 3. By doing that, and when we multiply the top equation, multiply everything by 4, we get 16x plus 12y is equal to 40. We multiply the bottom equation by 3, we get 27x minus 12y equals 3. If I draw my line and I add them, my 16 and 27 give me 43x. My 12y's are eliminated, and then that's equal to 43. And I can divide both sides by 43 to get x is equal to 1. So what we did is we looked to see what would be the easiest variable to eliminate, and sometimes it's seeing which one has opposite signs, change those equations, and then eliminate whatever variable you're looking to eliminate. Now we're going to plug it back in, and I'm going to plug it back into one of my original equations. I'm going to rewrite the top one down, and now instead of x, I'm going to plug in a 1. So we'll have 4 times 1 plus 3y equals 10. So 4 plus 3y equals 10. Subtract 4 on both sides. 3y is now equal to 6, and we can divide both sides by 3. So y is equal to 2. So our ordered pair is 1, 2. And again, you're looking to see what can eliminate. We're going to do one more example, And this is going to be number 59D. This is actually a homework problem. We have 9x plus 10y is equal to 4. 7x plus 5y is equal to negative 3. So again, the first thing I'm doing is checking. Can you add them together and something cancel out? If the answer is no, try subtracting. If the answer is still no, look to see what would be the easiest to get rid of. So if I look at my x's, I have a 9x and a 7x. Can I multiply anything with 7 to get 9? No, that's not going to work. Can I multiply anything with 9 to get 7? That's also not going to work. So now I'm going to move on to my other variable and check out my y values. So I'm going to do the same thing. Can I multiply anything with 5 to get 10? Well, I can multiply it by a 2. So what I'm going to do is I'm going to actually multiply it by a negative 2. So I'm taking that whole bottom equation by negative 2. The top equation is going to stay put. The bottom equation is now multiplied by negative 2. And you will notice that when you go to add it together, that those 10y's are going to eliminate, which is exactly what you wanted to happen. So we get negative 5x equals 10, and then we can solve for x. Divide both sides by negative 5. X is equal, I think I missed a number. Oops, wait. Sorry, this should be 14. So this should be 20, sorry. So 20 divided by negative 5 is negative 4. Now that we know x is negative 4, we're going to go back into one of the original problems and plug it in. I'm going to use the top equation, 9x plus 10y equals 14. Instead of x, I'm plugging in 4. So we have 9 times negative 4 plus 10y equals 14. So that's negative 36 plus 10y equals 14. We're going to add 36 to both sides. So 10y is equal to 50. Divide by 10. I'm running out of space. Y is equal to 5. So our ordered pair is negative 4, 5.